Good afternoon, Pradeep sir. Good afternoon, sir.
Good afternoon, sir.
Yes, good afternoon, Ranjit. कैसे हो?
Good afternoon, sir.
Good afternoon, good afternoon.
Sir, can we start the session? Good afternoon, all. I welcome expert of the session,
Good
Professor
afternoon.
Pradeep Kumarji, and all participants in the second session of FDP on design thinking. This is an ATAL FDP. And I feel myself fortunate enough to introduce Professor Pradeep with the participants. Professor Pradeep Kumar did his BE, ME, and PhD from IIT Roorkee and presently working as professor at IIT Roorkee. Sir has been to various esteemed administrative posts, which includes Vice Chancellor of Delhi Technological University, Dean Finance and Planning, Chairman of GATE, JE, JMAT exams. Professor awarded many times for being best teacher and was gold medalist of his ME. Professor also awarded by SAE Recognition Award, Eminent Mechanical Engineer Award, and many more awards for his research contribution. Professor visited more than 10 countries for various purposes of academic and research excellence. Professor's research interest includes advanced manufacturing, supply chain management, metal casting and welding, quality and reliability, and sir have supervised more than 50 PhDs. Sir, I welcome you, and we are very thankful to you for accepting our invitation for being expert in this FDP. I again welcome you, sir, and I request you to share your wisdom with us.
Yeah, thank you, madam. What I can read that Dr. Indu Bhuria, right?
Yes, sir.
Yeah, thank you, Ranjit, for giving me the opportunity.
Thank you, sir.
Can I switch off my video so that bandwidth should not be a problem?
Sure, sir, sure.
And just let me know whether you can view the slides or not. Are the slides visible?
So now it is presenting, sir.
Okay. Just I wanted to.
Yes, now slide is shown, sir.
Slide has gone now, right?
Yes, sir.
It will come again. I was just testing it.
Okay.
Now it will come. Right. So actually the topic of today is Industry 4.0, but Professor Ranjit asked me that you need to relate it with design thinking. So although I understand in the previous section, in the previous lectures, and because the course has just started, you will hear a lot about design thinking. I'm just giving you very important pillars basically in the design thinking. And then I will tell you about Industry 4. And in between, I will keep telling you how the design thinking is automatically inbuilt in Industry 4.0. Just starting a little bit, I'm not going much in detail in design thinking, just giving you an overview, the important aspects in the design thinking. Very first thing comes, what is design thinking? Although by now you may be knowing it, just repeat of it. That whenever we basically go for designing or redesigning, and when we use the word thinking, then it becomes a system. And when a system is there, there is a process. And we can take design thinking as a process. And important in design thinking process is, because design is nothing new. People are designing the product since ages. Only the difference is that earlier it was a push type of system. Means whatever the idea comes in the mind of the industries, they basically convert that idea into the product, and product is normally introduced to the consumer, and then slowly and slowly they become interested in the product, and they basically create the demand and they start using it. But now the things have changed. Everyone wants his own product. Customization is important. Individualization has become a key factor. So that's why the design thinking has become an important topic. Why important? Because whenever we go for the designing in the present era, we need to prioritize the customer need at the top, above all else. This process basically relies on observing with empathy how people interact with their environment. And also, two important pillars. There are four pillars. One is the empathy. Second is, it is an iterative, hands-on approach, means it's an iterative process. It's not that one time you design it, things will go. You have to involve, you need to collaborate, we need to rethink, reiterate, getting the feedback and keep on improving the design. So that's why I'm saying that it starts with the empathy and employs an iterative hands-on approach in creating the innovative solutions. Looking into the second bullet, we can say it is a human-centered approach. This means that it uses evidence of how consumer actually engage with the product. Rather than, I told you, push type. Earlier it was a push type of system. Now it is a pull type of system, unless it is a monopoly. If it is a monopoly, product is monopoly product, then you want to use it, no other manufacturer or seller is there, that is there. If the product is in the competitive environment, then it is a pull type of system. So it is basically important with the human-centered. Earlier, what was how someone else or an organization thinks they will engage with it. So earlier system was push type of system, because earlier whatever the organization or like this Apple, so they basically initially they had the good idea, they brought iPhones. So people were not expecting that iPhone will come. So that idea was pushed on, although people liked it. But it was a pushed on. But later on, after the first version, so many features have been introduced. And all these features were basically incorporated, or the latest version came into the existence because of the human-centered approach. They took the feedback, what else you want, what features you want. But to be truly human-centered, designer watch how people use a product or service. And important is, they are not, there is no inertia. They continue to refine the product or service because they want to have a good feedback, consumer experience. If you are responding to what consumer wants, if you are, whatever their expectation is there, this means you are not only your market reach is increasing, but your goodwill is also improving. Thus, we can say it is an iterative part of the design. It favors moving quickly to get prototype out to test rather than endless research. Because once it is a push type of system, for any interruption, any disruption in the technology, you keep on waiting for 20 years that, okay, something new will come. I will show you one example. So something new will come, then only we will incorporate like that. So it is a continuous process as well as iterative process. In contrast to traditional problem, already I mentioned, which is a linear process. First you identify the problem, then go for the brainstorming, then develop the model, solve the models, optimize it like that. So this is a continuous problem solving process, and as well as based upon the feedback. There are basically four pillars in the design thinking. First pillar is empathy, as I already mentioned. That we need to understand the issues from the consumer's perspective, from the user's perspective. We need to put our foot in their shoes, and then understand what the consumer wants, what actually he is looking forward. Because when the consumer requirements are there are two type of requirement. One is spoken requirement, another is unspoken. Many times, because consumer is layman, he only knows that I want something that I can use it, but technological part basically is missing. So he do not understand. Like I always give this example in the class, that if you ask any consumer that what should be the strength, suppose you are selling a structure, he says मजबूत चाहिए. कितना मजबूत? बहुत मजबूत. So you don't understand 50 Newton per millimeter square is a ज़्यादा or 40 Newton per millimeter square is a lower. So that is basically unspoken need that you have to understand, because consumer will give you a certain set of requirement, but what he doesn't know, what he has not mentioned, that you need to include. How you can include? Because you need to basically have this empathy, understand what he is want, what application is. So accordingly you have to decide what strength basically he is looking forward, not jada or kam. These are the basically relative things. That is the first pillar. You need to understand from the consumer's perspective both spoken as well as unspoken needs. Second pillar, when we go for the design thinking, is collaboration. It should not be a one person approach. I am a designer, I am sitting in my office, I know what consumer wants, I am doing everything in the design and developing prototype, whatever. You need to involve the people. You need to collaborate. Somebody may be expert in one area, another is another area. Suppose marketing people, they know more, they have the feedback directly from the consumer. They have the feedback from the warranty data, because the product is already in the market. Whatever the warranty, whatever the failure or any problem is there, that goes in the warranty. They can invite the people for the discussion. They can collect the feedback from the sales department. So we need a collaboration when you are designing. So collaboration not only from the downside, from the marketing and the field service, sales after service, maybe from the other section like purchasing, manufacturing, testing, inspection, and shipment. From all these areas, you need to collaborate. Only thing is that if the perspectives and skill sets are aligned, it should not be like that, if I am going in one direction, somebody is going just in the opposite direction. So then collaboration will not help. So it will be the same mindset, collaborate it. Okay. Then the third comes inclusions. Inclusion means don't snub somebody. When you are collaborating people, some person gives the idea. Maybe at that initial point, you say, oh, idea is just useless. Don't snub. Every idea counts. Every idea counts. Keep noting down all the ideas. Maybe some idea may come up. Maybe later on you can discard if it is not fitting into the domain with respect to because consumer is the priority. You need to basically, whenever you are extracting the requirement, what consumer wants. So that basically you already know it. You are collaborating with the people with the same skill set, with the positivity. But don't forget that include every idea. Some idea may be wrong, may not be practical. Later on, those ideas will automatically be discarded, will not be liked by the consumer. So that is why I am saying it is another pillar. And fourth pillar, final pillar is iterate. I told you, it is a continuous iterative process. So not only you iterate yourself, but take the feedback. That okay, what I have designed, this is my early stage, first prototype. Now send to the consumer. They will give it their feedback. Take the feedback in a positive manner, try to basically redesign it or try to include all the feedback into the system. That getting idea out, whatever your idea is there, out and open for evaluation. Be very open to the system. So once your idea is out, open for in the system, certainly the feedback will come. If you are positive, suppose 20 feedback is there, you may say that maybe around 15 feedbacks are not possible to include. Okay, include 5. So these are the 4 pillars, basically the entire design thinking basically is based on. Again, I'm just summarizing here. Empathize with people's needs. Empathy. And that is the most important part. So not only you empathize, but communication, because any gap in the suppose consumer wants X, marketing people understands X plus 0.1, and marketing people communicates with the designer, he communicates with X plus 0.2. No, whatever the consumer wants X, the communication means translation of consumer's requirement into the designer requirement should be 1:1. Collaborate with other across discipline. I mentioned skill sets. I'm saying across discipline also, because you need to collaborate when you are designing with the purchase department. If you have, as a designer, you selected one material, purchase department said no, material is not available. Manufacturing people say we don't have those machines that can give this much specification. Inspection department say no, we don't have any equipment that can test all these things. Packaging department says we need to have another infrastructure to develop the packaging. Shipment says the size is so large, it's very difficult to ship. You have to design the trucks. So when you are designing, you need to collaborate across all the stages of the industries, all the disciplines, skill sets and perspectives. Then every idea counts, include every idea. Evaluate, don't snub the idea. Take the idea, evaluate, see whether that evaluation is positive, whether it can be, if not, fine it. And finally, repeat, iterate and test. So now you have to, because once the idea is, everything is formed, then you have to test the solution. But always keep in mind what exactly the human needs are, what the consumer wants. So these are the basically pillars of the design thinking. Now when I talk about Industry 4, I will keep telling that how all these things are automatically inbuilt into the system. Okay, I start with the story. And the story basically is rise and fall of Kodak. You understand Kodak is a company. Kodak used to be a company. I'm not saying it's a company. It was a company that used to manufacture what? Cameras as well as the camera films. Okay, so this is the story about the rise and fall. So that is basically back in the 19th century. The Eastman Dry Plate Company, the initial name of Kodak company was Eastman Dry Plate Company. They produced the first camera that was not invented for professional, only for the common. The focus, the objective was we want to innovate something that basically will help the common people, not the Bollywood or not the filmmaking or nothing, only the common people. That was the idea. Okay. So they produced first camera way back in, although the size of the camera was very large, there was no film. They used to have a plate, gelatin plate. So, and this Eastman basically, at that time, there was a trigger, disruption in the technology. Initially, basically, if you see on the top, right bottom picture, is rectangular photograph. Basically, that was a plate. So that dry plate process was invented by Maddox in 1871. So basically the system was, they used to fix this plate at the back of the camera, and then they used to expose it, and once after that they wash it, negative was produced, then they produce the positive. So 1871, the Maddox basically invented this dry plate system. After 7 years, another researcher, that is Bennett, he improved the coating process, the dry plate coating process. And the Eastman, George Eastman, basically he developed and patented a machine to coat the plates after 1 year. So this gentleman, basically George Eastman, his only contribution was that development of machine that basically coats all the plates. So that's how basically beginning started. Then a businessman, Henry Strong, basically, he was very impressed with the Eastman commercial manufacturing of dry plate. So they both, basically, he was a businessman having the money. So he joined basically with the Eastman, and they formed the company. January 1, 1881. These two guys basically uh, uh, formed a company known as the Eastman Dry Plate Company. That was the beginning of the Kodak. Now, again, disruptions. The first disruption was the dry plate gelatin process they used, dry plate innovation. So anytime any disruption in the technology comes, means some new innovation is there. So first basically disruption in the technology happens, that a switch from dry plate to the roll films. The same company, after 3 years, they basically patented the first film in roll form. So they produced the film. Not only they started the film, but also started manufacturing the paper, means photographic paper. So they kept the name of the film as well as the name of the paper as a Kodak, the brand name as a Kodak. And those cameras were so successful, the word Kodak they incorporated into their company name. So instead of Eastman Dry Plate Company, it became Eastman Kodak Company. So they changed the word Kodak, they introduced the Kodak, because dry plate has gone. Because dry plate, that disruption in the technology happened from dry plate to the film, black and white film. Initially it was a black and white. So now the new company basically was established in 1892 by targeting non-photographer. Important was consume, because photographers were limited. So if it goes in the masses, the marketing will be more. So that's why it's written Kodak created a huge market. So Kodak basically, they brought photography to the common people. Same way, just like the Ford Motor brought cars to the people. So that was the beginning of the Kodak company, Eastman Kodak company. Naturally, when some thing has been started, it grows. If you take care of that thing, it will grow. So the second phase was the growth. People love to take photos. And as they become richer, they took more photos. The George Eastman, what he said, you press the button, we will do the rest. That was the style at that time. Naturally, if you sell more cameras, more papers, more film, so Kodak basically made more money and kept growing and growing. So demand increased every year, every day. So naturally, they keep on getting the score of money. Another disruption, second disruption happened in 1935, after almost, you can say, 40 years. So now it was basically Kodachrome film. So they brought the color film, non-color to the color film. Initially, there were only 4 color. Those who are older, you people may not be knowing that earlier, if you just go through any Bollywood film, so when the casting is there, who is the hero, who is the heroine, etc., and they finally they write, Eastman colors, because the entire film basically was produced on Eastman color, and at that time there was only mixing of 4 colors. So it was introduced and became the first color film success. Just like Gillette made great money by selling razor blades, because razor you will buy once, and consumption is basically more consumption is on the number of blades you are selling. Kodak made great money by selling films. The main source of profit was not the camera. Camera is a one-time purchase. It was a continuous consumption of the film. So it is life is a game. Money is how we keep score. Today I have 1 crore, tomorrow 2 crore, like that. So they keep collecting the money. But negative part of the Kodak was they were not understanding that another disruption is happening around the world. Kodak kept neglecting digital technology. They were so happy with their success of the film because they were getting money. They said, why should I bother about when I am able to sell everything? So Kodak's management inability to see digital photography as a disruption in the technology. Even as, and I will tell you in subsequent slide, their own employees, own research team, they basically developed the digital photography first. They innovated it, but Kodak management did not take care of that. Even as its researchers extended the boundaries of the technology, but they say, oh, we are happy, we don't want to change. Kodak continued producing film roll cameras. So naturally, they are not, because they are not ready to change themselves. So what happened? After almost 110 years, they fired 20,000 people because a lot of competition started. Fuji in Japan, they adopted the digital and they lowered their prices and expanded. Kodak also later, when Kodak basically realized what is happening and Fuji has taken the entire market of cameras and films, so they basically started to respond to the digital, but they entered in China, but they lost. So that is basically normally we say decline phase, the fall, ugly picture. In just 15, 20 years, up, the things goes like that. The share prices went down from 2000 onward, and employees basically they kept on firing because they were in the loss. And within just a few years, their business model disappeared and they went bankrupt. So in 2012, they filed bankruptcy and also declared that we will not remain in the photography business. Now question, so many facts are there. What happened after facts? So, okay, no doubt, no problem. There are many companies, just one story I told you, Kodak. There are more than hundreds company, they introduced, they had the good growth and finally they went out. So they basically they blew its chance because they were in the denial mode, not ready to accept the changes that are happening across the world. Steve Sesson, he was an engineer in the Kodak company. He invented the digital camera. Their own employee invented this camera. But what happened? It was a filmless photography. What was the management reaction? Oh, it's cute, but don't tell anybody. We are not going to include it. Okay, you have done it, fine. But it looks nice, but don't tell to anyone. The leaders of Kodak failed to see the digital photography as a disruption in the technology. And result, you see, they are so focused on the film success that they missed that bus. They missed the digital revolution. After they started, their own engineer invented it, but they missed it. right? Now, as I mentioned, there are many other companies like HMT, Bajaj, Dynora TV, Murphy, Nokia, Rajdoot, Ambassador. So many companies are there. They have the similar fate. They had the similar fate. There was no shortage in the quality of all these companies, yet they are out of the market. They are finished. What was the reason? The reason was only one. They did not change themselves over time. You have to have basically 1:1, because if you have to survive in the market, you have to look around what your competitors are doing. If you are not able to satisfy the consumer, that's why the first pillar I am talking about. If you are not able to satisfy the consumer, there are many others who will provide the things that will satisfy the consumer. Because consumer demands are changing every day. You need to respond to the consumer, what he wants, not what you are selling. Because they were in the mode of, we are selling the film, if you want it, buy it, otherwise enjoy it. So consumers say, no, I want digital, I don't want cameras, I don't want films. So that's basically the only reason was they did not change over time. So many examples. 5 or 10 years ago, there was no such place where there is no PCO. Every corner, every street corner, there is one PCO. When the mobile phone came, the PCO gone. All these PCO people, what they started? They started selling the recharge coupon. Now even the recharge has started online. Everything is done with Paytm. All money basically now digital payment system has started. It is so many things have come. Your currency note is replaced by cards, and cards are now has gone digital. So earlier the time, basically there was a long time to reach the technology in the hand of the people. Now time has reduced to 1 year, even in some cases 1 month, in some cases next day. So now the technology to reach to the common people, the delay in that this basically in that time to reach to the consumer has been reduced, much reduced. Just a pictorial representation that how the things were earlier. It was only 5 MB hard disk in way back in 1956. You can see the volume and the size and the weight. Now you are having what? 1 terabyte. Just microchip is there. Some more companies who are there, very established company, Kodak, Nokia, Xerox, Yahoo, Sears, JC Penney, they are nowadays not in the market. They finished. And what basically the Ford has mentioned, Henry Ford, of the Ford, basically the owner of the Ford motor. What he said, if you always do what you always did, if you keep on doing the same thing, what will be the answer? You will always get what you always got. So what lesson we can learn? That external environment can be deceiving. Even if you are basically receiving a lot, or you have a market, you are still getting hold of the market. But just look beyond. Your vision is important. Change happens. Always consider this. The changes are bound to happen. And you need to be ready to adapt that. Sometimes your greatest strength can be your weakness. What happened to Kodak will happen in a lot of industry in the next 10 years. I say in the next 10 years, it should be 5 years, better to say. And most people do not see it coming. We know it, but many people will not believe it, and those who will not believe, they will washed off. Digital revolution is already at the door, and we are at the beginning of the epoch of digital revolution. The keywords here are very beginning, because when we are saying we are at the very beginning, important is the keyword. It seems to us that everything has already happened and went so fast, because if somebody, I discuss with somebody digital revolution, yes, it's already there. We are basically doing all the payments through the digital technology and so and so. No, but it is only a start. It is only a start. Now, Apple Pay come to life very recently, but none of the sellers at the box office is surprised that you pay by your smartphone. Very common, it has happened. Okay, but everything that can be digitized will be digitized. Everything has not been only some payment or some application has been started, but not every application has been started. So wherever the possibility of digitization is there, it will be. That's why I mentioned very beginning. Your medicine area, security, education, army, absolutely wherever the possibility of digitization is there, it will be digitized. It will be digitized. Right? And finally, those who basically, here basically important is the property right, patent. Those who possesses the property right on information or new knowledge, they will define, because those means companies. So the companies which basically go for the patent and property right on all these digital information, like in the medicine or security or education, etc., the entire game is basically with them. The entire economy will be controlled by those companies. Now, imperatives. Some imperatives that I already mentioned. Whatever is possible, it will be digitized. One more thing is artificial intelligence. Things will happen by using the artificial intelligence, like in the health sector, electric cars, education, 3D printing, agriculture, jobs, and that is nothing but your fourth industrial revolution, or you can say industry 4.0. Many people use the word exponential because changes are happening at an exponential rate. Every day, when we talk with the people, yes, for this there is an application. For this there is an application. All banking infrastructure, they have the application. Even in the education, lot of applications are there. So softwares basically using AI, they basically are going to disrupt most of the traditional industries. Like Uber, everybody know Uber. It's basically a company that provides the transport services. It is a software tool. Ideally, it is a software tool. They do not own any car. They don't have any car in the name of the Uber company, and are now the biggest taxi company in the world. Even the Airbnb is the biggest hotel company in the world, although they do not own any properties. See how the things change. Autonomous cars. Way back in 2018, first self-driving cars, driverless car basically. In California, it was basically, they tested it. But maybe another 5 years, then disruption in the technology will be there. You will not want to buy any car. So when cars are available, drivers are available, or driverless cars are available, why should I buy a car? Wherever I want to go, I will call a car and will go to the location. So once these cars will come, naturally all these cars will basically move on a fixed route. So when they're moving on a fixed routes, the possibility of the accident will be less. And suppose Insurance company says, okay, no, we are not going to change our business model. We'll charge the insurance as we used to charge earlier. They have to change because number of accidents have been reduced. So if they are like in the Kodak, if they are sticking to their basic model, they will be in trouble because insurance will become 100 times cheaper and their existing car insurance model will disappear. Like in the health sector. Too many, even for the corona also, they developed the kit. And you just use the kit and it is basically attached with the application, send the data there, you get the results. And it is already in the market. There will be companies that will build a medical device. There is a company, Star Trek. They already have a tricorder. You buy the tricorder, use their application, and do it. So this tricorder works with your phone, and which takes your retina scan. So this basically tricorder, you just put a blood sample in that machine, or you breathe into it, and the entire data will be processed by the application. 54 testing, 54 biomarkers, your hemoglobin, whatever, TLC, DLC, whatever the test using these. So they will identify everything. So they will not only give you the report that, okay, your 54 test of your blood is there, but based upon that report, they will advise you that they can tell you probably you are having this problem or this disease. Maybe sometime in future, they will also advise you that, okay, you need to go for these medication. These medicines should be prescribed to you nearly for free. 3D printing. Another example is 3D printing. In just last 10 years, the cost of 3D printer has reduced from $18,000 to $400 only. But as well as it became 100 times faster. All major shoe companies started 3D printing, like Adidas. So they have developed the application. You just download the application, select which size you want, which color you want, what design you want. There are so many alternatives they provide you. And based upon that alternative, you select it and finally they say, okay, this is the cost. And then you order it and you will receive it. Spare airplane parts are already 3D printed in remote airports. Now you need not to wait for the component coming from the major cities. They have the 3D printer. They have the part designs files. Any part is missing, they use that particular file, they 3D print it, use it and go. Even the space station now has a printer that eliminates the need for the large number of spare parts. See, in 2006, none of the company was in the market. In just 5 years, because WhatsApp is very old now. So in 5 years, they captured the market. Just a comparative examples. Time to reach 100 million customer. Telephone, landline telephone, it took 75 years to reach 100 million customer. World Wide Web, it took 7 years to reach 100 million customers. See how the technology basically is capturing the market. Facebook took only 4 years. Instagram took 2 years to reach 100 million customer, and the game Pokemon, whatever, Pokemon Go, in 1 month it reached to the 100 million customers. So the idea of showing all these things is how technology is changing, how technology is reaching in the hand of the customer. So that time has been reduced. Everything will be smart in future. I already mentioned, initially there was a technological push. Push was from the company. Whatever I designed, whatever the idea I have, I designed it, I produced it, sent to the market. But now only technology push will not work. basically both market pull. Market pull means what customer wants, what market wants from the company, what product I want, what type of customization I want in my product. So when both the push and pulls are there, things will go smart. You have the smartphones, you have the smart homes, smart cars, smart factories. If coming to the manufacturing, this is the scenario of the traditional factory. I should not say traditional, I should say it is just industry 3 scenario of the factory. Because computers are there, robotic system are there, all the PLC system was there, but everything was wired. Means everything was connected. The instruction basically are passing on from one module to the another module through the wires. So that was the scenario of the traditional factory. But there is a challenge. And what are the challenges? Product life cycle. People want that, okay, if I am ordering today, you design in as fast as possible. I can't wait for 5 years that new product will come. And when you say product life cycle, means you have to reduce the design, setup, production, everything. Individualized product, customized products. Global, if you are, that's why I always say, if you are not able to sell, somebody else will sell. So there is a globalization is there. Online market, if you are fond of going for online purchase, if this buyer is, this seller is not selling, somebody else will sell. So there is a globalization, international pressure is there. These are the challenges on the modern world. And certainly quality is there, that everybody looks for the quality. So when these challenges are there, you need to change the industries. Not like in a fixed location. Earlier, there used to be big industry in Bombay, and everything is manufactured there and being shipped to all parts of India. No, now people, they say you have the basic industry somewhere, but a small basically work center, almost near to the not all, but majority of the city, so that you can supply within 24 hours. You can't wait for 5 days. That's why I always say that quality was always important. Cost was always important. People look for the cost. People always look for the quality. But important is the delivery. The third dimension added the delivery. The delivery means lead time between placing the order and receiving the order. And that's why the challenges are there. You have to change the locations. Instead of monolithic, you need to be modular. Okay, you need to be distributed type of system, and above all, wireless. I am sitting in my office, I have my lab there, everything basically has been duplicated on my machine. I can pass the instruction, there need not to be any person available there. I can pass the instruction, all the instruction will go through internet. The machine or the motor will start by clicking here only. So that is the wireless. And here basically the importance of ICT, information and communication. Because there is so much improvement happened over the years in ICT technology that things are becoming fast. That's what Industry 4 is there. So when we talk about Industry 4, all the design thinking that we are talking about, you are collaborating with people, and without collaboration, without empathy, without collecting the need, you can't proceed. That is a prerequisite of anything. So what are the challenges that already I mentioned? And important challenge is the competitiveness. Your production, naturally, if suppose I say shorter product life cycle time, that is one challenge. But instead of saying shorter product life cycle, I say competition is a challenge. Because if my product I can deliver in 10 days, somebody delivers in 5 days, so he will get the lead. So that is obvious, because I have to check my customer demand, not only the customization, not only the empathy, but they want the product next day. So when all these things are there, we have to basically change. We need to change it. We need to improve our efficiency, shorten time to the market, and important is the flexibility. Not only one product, same product I am selling, manufacturing, selling. No, because customer things are changing. Markets have become volatile, and it is changing. Manufacturing is changing faster than ever before. That we should keep in mind. Then just a comparison of all this industry 1, 2, 3, 4. I'm just focusing on industry 4. So, right? So that is the fourth revolution. And if you see on the right side of this, that basically mentions the degree of complexity. The degree of complexity, not only basically we are moving ahead, but complexity is also increasing. That is negative part. System is becoming more complex, more issues are coming, more different type of issues are coming. So that industry 4 basically it is based on cyber physical system. So we are currently implementing the fourth revolution. And this fourth revolution is characterized how? By the application of already mentioned ICT and known as Industry 4.0. Although this photograph is small, basically what we are doing, production system that already have computer technology are expanded by a network connection, internet connection. And every component, every part, every sub-assembly of my production system has a digital twin on the internet. Digital twin, like see if you small photograph, there is a motor. And a digital twin is existing on my computer through the internet. So I can check every part here. I can push the start button right from here in my office. So through the internet, this possibility is only through the network connection. So everything we are having digital twin, and these digital twin allow communication with other facilities. This is the next step in production automation. Earlier, whenever we talk about automation, we only talk about robotic system, material handling. But this is in one more step ahead in the automation. The networking of all this system leads to the cyber physical production system. Production system exists physically, but there is a digital twin of the entire physical system on the internet. And therefore, that's why we say that now we are having the smart factories, in which production system, components, and people. So we also, because now whatever I'm communicating through the network. So people are communicating, production system is there, components and working, and production is nearly autonomous. That is basically Industry 4.0. I'll just take a pause of 20 seconds because there is an urgent phone call. So I'm joining just in 20 seconds. Sorry for interruption. Then just coming for the history, how basically it started. And see, here also you see, just in 3 years, everything changed. Can you hear me? Anyone can respond.
Yes, sir.
Okay. Okay. So that basically the Federal Ministry of Education and Research, actually German name is BMBF, but the English meaning is Federal Ministry of Education and Research. So how basically visionary these people are there. They initiate the Science Union to identify future high-tech trends with high impact on society. So that was the vision, that what is the future in the technology, in the industries. So that idea came, that the idea they floated, and just in one year, first appearance of the word Industry 4.0 came. This Science Union, like our DST, they submitted the final report in another 1 year. That okay, yes, this is a practical idea, applicable idea. So they have given all the what the idea is there, what should be the strategy, how it will be implemented, etc., etc. Then they developed the report securing the future of German manufacturing, because they want to take the lead and they want this future Germany. They recommended for the implementation. Okay, say yes, your report is now approved. We need to secure the future. So, okay, you implement whatever you have given in the report, you implement. They given the order in 2013, and within just the a system of processing and approval, they basically applied on the 3 industries, platform industry 4, and they got the success in 2014. And although a lot of money invested in developing the technology, that is almost by various people, basically, their other industries like Federal Ministry of Economics and Federal Ministry of Education and Research, they poured the money, almost 400 million euro they invested to develop the technology. That's how basically Industry 4 in just 3 years, they implemented it. Now question comes, what leads to, as I already mentioned when I was telling you the story of Kodak, that any time any disruption in the technology is there, this means some innovation. Something new is coming. So Industry 4 is coming because of the four disruptions happened. The first disruption was the astonishing rise in the data volume. Lot of products have the chip installed. Suppose I purchase a shoe. Suppose there is a small chip inside it. So that chip basically collects the data. How frequently I am using the shoes, how long I am using, what are the problems coming in the shoes, what are the various pressures, etc., etc. So lot of data just by one person using one pair of shoe. So imagine that if 100,000 pair of shoes has been sold, how much data? That's why nowadays there is a demand of big data. Collection of data is not an important. Important is how to analyze it, how to segregate the data in an analysis form. So the stunning rise in the data volume, computational power has increased, connectivity has improved, especially new low power wide area network. So that is one major disruption happened. Another happened, emergence of analytic and business intelligence capabilities. New field of education and research. Master's program are there in business analytics. So a lot of new technique, new softwares have come into the market. Third is new forms of human-machine interaction, such as touch interface and augmented virtual reality system. Before installing, you can virtually see how it looks like. Even that lens card, I think that is a company. If you want to buy, you just go there, you can select it. So there is a possibility you can keep on switching the one glasses on the another. So whatever suits to you, you can select that. So that is touch interface, virtual reality system. And finally, improvement in transferring digital instructions, like in the 3D printing, like what we are doing right now, to the physical world. So these are the major four disruptions that happened in the system, and that leads to the industry 4. Then question comes, why? Why we want industry 4? And anytime when we say why, it must be supported by some advantage. If some advantage is there, only then we will go for implementation, right? First advantage is it helps manufacturer with the current challenge by becoming more flexible. Because when you are directly, your customer is in your, because you are basically interacting directly with the consumer, not through the survey, not through the reports, not through the marketing. Your chip is there, you are getting the direct feedback, direct data is there. So you are basically feeling more data is there, and you can respond to the changes as per customer immediately, reacting to the changes. It can increase the speed of innovation and is very consumer centered, and leading to the faster designing. Whatever your design thinking is there, but if you implement design thinking along with the industry for implementation, things will improve. Workers can become coordinator. Yes, that is, you can take advantage as an advantage or disadvantage, because now no worker is there. I am passing the instruction, start the machine, only worker is standing there. That okay, if by chance any catastrophic failure is there, I will be able to handle. Maybe sometime there is a malfunctioning of machines and software. Maybe some cyber security issues are there. So workers, they are not now worker, they will become the coordinator. And when they will become the coordinator, basically their life balance improves. They, instead of blue collar, they become the white collar people. It is a sustainable long term. It helps in finding the solution on any challenges that arises. That is why industry 4. Now coming to the technologies. What are the technologies that we want, if we want to industry 4, what are the technologies or what are the enablers? These are the 9 technology. I'm not saying all the 9 you need to know, because every implementation of every technology means a huge cost. So like Bajaj Motors, they only introduce cobots, collaborative robots. So you can use all the 9, you can use only 1, 2, 3, depending upon your requirement, like IoT, big data, virtual reality, vertical and horizontal reaction, simulation also, cloud computing, edge computing, additive manufacturing, cyber security, all these things, because cyber security has become an important thing, because now your all the confidential informations are going through the net, and there you every day you are listening that hacking of this website or that website is happening. So you need to develop your system in such a way that no hacking is possible. You need, even if suppose hacking happens, you should have the right rules, regulation, laws, because earlier nobody has basically approved any law, because nothing, no technology was there. Now IT rules have to be changed. Every day new rules. In India also, you might be noticing a lot of rules are coming, that if you do this, this is the punishment, like that. So when we go for these things, fine, we have the technology, we can implement some other. What are the challenges? One of the challenges is the economic challenge. As I already mentioned, this is a basically huge investment required. All this technology requires huge, high economic cost. Although the benefits are much higher, but initially there is economic cost. Risk is also there. You are basically changing the entire things to the new model, and certainly risk is there. If you are not basically experienced enough, you may fail, and the moment you think that I am failed, the entire money gone. Unclear economic benefits. sometime, or you can say sometime too much investment that I don't dare to take the risk. Okay. So these are the economic challenges. Of course, some social challenges are also there. Privacy, self-explanatory. General reluctance to change by stakeholders, depending upon the risk-taking capabilities. Threat of redundancy of the corporate IT department. Now, IT department in the company say, what we will do when everything is online? So, what is the role? So, they feel discarded in the companies. And so, another important is loss of many jobs. That is clear possibility is there, that because everything is automatic, workers, they don't basically need to start the machine, off the machine, continuous stand over there. No. So that's, I mentioned that they will become the coordinator. Yes, for the, at least for the blue collars workers, it is a problem. Of course, every system in every country, they are having the political issues. And for good sake, at least in our country, we are basically framing new rules, regulations, standards, certification process, legal issues. The things are being taken care of, but still that are very 5-10%. Still a lot of work need to be done on all these aspects. And last challenge is the internal challenge, the management challenges. So management commitment is required. If management is not committed to change, like in the Kodak, the management was happy, okay, you have done a good job, but no, we are happy with the market. So they did not notice that change has already come. Reliability and stability needed for critical machine-to-machine communication. Because if I am passing the instruction, so my networking system and my sending system and receiving system should be in 1:1. Any small change in the communication, any deviation in the communication will spoil the entire thing. Need to maintain the integrity of production processes. Need to avoid any IT snag, as those would cause expensive production outages. Need to protect industrial know-how. And that is, I always focus on this, lack of adequate skill sets. So it is here basically the role of the academic institutions are there. We need to design new programs, academic program, maybe bachelor's, maybe master's, maybe PhD program, in all these areas, cyber security, IoT, AI, all these areas, so that we can basically provide the manpower for future. Yes, there are people trained in this area, they can be employable. And that is another challenge is always, this is always a challenge. Management most of the time is not committed. They are just looking for the profit. They don't want to invest in the new technology because they don't want to take risk. So these are the challenges that basically are very important to understand for the implementation aspect of the industry 4.0. Lot of development across the world is happening, like SMLC. That is happening in the Europe. So they have developed an entire Europe, they have the coalition known as SMLC, and the focus is Industry 4. China basically has Made in China 2025. So they have basically this development with a name like that. And manufacturing innovation in the East. In India, basically we do make in India type of things, but still not related with Industry 4. But whatever is happening across the world, whether it is the East, West, or China, all share a common pursuit. Everybody is looking for the smart manufacturing. Everybody focus is the same, but the style of development, innovation and implementation aspects are vary from the country to country depending upon their internal conditions. See how the things have been changed from digital to physical. One example, this is LM Motors. So they build car almost entirely through 3D printing. They use the 3D printing entirely, entire car has been produced. So when entire car has been produced, so the you can say the time between collecting the responses from the customer and bringing the first car in the market is reduced. It can build a new model from scratch in a year, in just 1 year. Any new model they think they can produce it. Far less than the industry average. Otherwise, industry average to bring a new car in the market is 6 years. Still, these two bigger companies, Vauxhall and GM, although this LM Motors entire parts have been produced by this, but these two companies still bend a lot of metal. They still use the traditional things. But now they are having a mixed type of approach, but also use 3D printing and rapid prototyping to minimize their time to market. So 6 year average was there, but now bigger companies have also started, okay, out of 50 part, 20 parts we are producing by 3D printing and 30 parts in the traditional. So instead of 6 years, they have reduced their production time or product life cycle time 2 years. So they have reduced it, but it's possible. Already I mentioned the example of Adidas. This is one more example, like creating the perfume. This perfume company, they have given the various alternatives. You select it. So when they have the various alternatives using the application, so they calculated they can produce 36,000 unique perfume package per day. And 24 hour after once the order is there, that how it's possible that within 24 hours you will get the delivery, because they have established the small smart factories nearby across all the cities. So anything they get it, basic raw material is available at every place. Once a particular perfume is ordered, the instruction passes digitally to the closest smart factory. They do it and send it. Okay. This Adidas, already I mentioned the example. The customer can design their own shoes. You need not to have a design thinking. You need not to contact it. But you have given the various alternatives. Suppose 1,000 alternatives you have given. Customer wants, okay, because you are a company, I want one more alternative. So you can take the idea from the customer, because you are a customer-centered company. So next time you are having 1,001. So it's not only that once they have developed all the application and smart factories, only 1,000 alternatives are possible. You keep on, because I told you it is a repetitive process. They can design their own shoes. Since the customer wants to receive his personalized product on the next day and is faster, long logistic chains no longer acceptable. Nobody can wait for 20 days or 1 year to get the shoe. Thus, Adidas decided to open various speed factories in Germany close to the customer using cyber physical production system. All soft files are with the company. Automatically the software takes care of that where the customer is there. To the nearest smart factory, the instructions are there. They have the material, they do it and send it. This is how the main screen looks like. So you start with the size, you start with the design, check the colors, and once everything you have done, it will tell you that this is how your final product looks like. And not only it tells how your final product looks like, also it tells the cost. If you agree with that, okay, otherwise change the design. So you have many options to do it. Another platform that has been changing because of all these things, that is pay by use. Means, or I can say the system has been changed from capital expenditure to the operating expenditure. You need not to buy. Companies are not selling the costly equipment to them, like SAP. SAP software is available. So you need not to buy the entire SAP. You say, okay, I just want inventory model. I just basically customize your software, SAP software. Only I want that inventory or my salary management system. So they will modify, they will give you the access to only the salary management. So you can use, you need not to buy it. You have to pay annual rent. Okay, using the SAP, only one module as per your requirement, salary or maybe inventory, whatever. Pay by use. Like in my department also, we have so many photocopier, but we don't buy it. No company sells it. They are not ready to happy to sell it. They say, okay, we will install, we will maintain. Only you have to pay the per copy things. So they come every month, they check how many copies you have taken, they send you the bill. Okay. Rolls-Royce basically, they initiated this approach. Like this Atlas Copco, they are a manufacturer of air compressor. They are moving away from selling the equipment directly and instead is billing only for the compressed air that is being consumed. If you want air compressor, they say, okay, fine, we'll send you. We'll only bill how much you are consuming it. The machines installed at customer site can monitor the flow of compressed air and adjust the output according to the customer need. Means everything, if you from the beginning till up to now, you see that everywhere the customer is there. Things have become so customer centric. So if you are not customer thinking, if your thinking process, designing process, manufacturing process, delivery process, not customer centric, you will be out of the business. As already I was mentioning, Bajaj, they took the lead. So actually they were limited in the space. So some ladies, some boys, some gents, male, etc., they are working. So they introduced a cobots, collaborative robots, because the space was limited. So they have the overhead robots. So it was not like that all the cobots, basically collaborative robots, were doing all the job. No. Whenever there is a need, suppose the part is heavy, so the worker standing over there, they can use the robot. So that's what it's mentioned. There is a human-robot interaction within a shared space where humans and robots are in close proximity. And these cobots are used for material handling, deburring processes, vision application, bolt tightening and welding in cooperation with it. It's not AI based. Whenever I need it, I use it. That's why it's mentioned in cooperation with employees. And a lot of benefits. The result, first large factory application of cobots in India. This led to the enhancement in productivity. Earlier, they used to basically assemble 507 vehicles per person per year. Now 804 units per person per year. So that basically the productivity increase. Ergonomical risk. If suppose it is very heavy, if you lift it, so you may have some trouble. So it reduced the ergonomic risk, improved ease of operations for women staff. So that is the benefit. Now question comes, fine, we know the industry 4. What is the next? What will come next? Naturally, industry 1 was there. What next? Industry 2. What next? Industry 3. What next? Industry 4. Now somebody asks what next? I say Industry 5. Yes, Industry 5. I'm not, don't say, think that Industry 5 will come. It has already come. Already Google has shown the application of Industry 5. And what Industry 5 is? The interaction and collaboration between man and machine. Here the AI is more focused. Means machine is taking the decisions also. And in one of the conferences, he shown this application. On one side, there was a machine. On one side, there was a human lady. And that lady basically wanted to fix the appointment on a salon. So when she rang, she was not knowing that somebody, the machine is answering. So when she stop, so I want to fix the, you can say, appointment for my customer. So the machine says we are busy at that time, we don't have the slot. What are the possibilities? So the machine is discussing with the human being, and finally they fix the slot. And the lady that was talking on the other company, she was unaware of that somebody, it was not somebody, it was a machine talking. So that basically is the human collaboration between man and machine. The fifth industrial revolution will be focused on the cooperation between man and machine, as human intelligence works in harmony with cognitive computing. Okay. The next wave already I mentioned, how we collaborate and how we define the rules, because machine will not automatically take the decision. Here basically you have to tell them using AI. Under different scenario, you have to respond like that. So we need to define the rules between human and machine interaction. Already I mentioned an impressive example during Google presented in 2018, where a voice assistant called to make an appointment, and the woman answering the call did not have a chance to recognize that she was speaking to a robot or a machine. Now, very general thing. Question comes, do we have the recipe for change? Suppose if we want to change ourselves, we want to implement something, what we need? We need these 5 things. We should be visionary. We should have vision, what we want. We should have the skills also. We should be motivated. Incentive should be there. We should have enough resources and a right action plan. Only then change can happen. If any of the one thing is missing, something else will there. Like, say for example, if you do not have a vision, everything you have, you will finally be confused. I have the skills, I am motivated, I have money, I have the right action. But in which direction you have to lead, you do not know. If you do not have the skills, then an anxiety will be there. If you are not motivated, a resistance to change. And if you do not have money, infrastructure, you will feel frustrated. I know everything but don't have the money. You feel frustrated. And if you do not have any action plan, it means you are basically going for the false start. So if you want any change that happen, you need to have all these 5 skills. That is all I wanted to say for today's lecture. Thank you. Stay safe. Any
Thank you,
queries
sir.
you can ask.
Yes, any queries from participant side, please ask. Yes, Mahi Upadhyay, you raised the hand. You have any query, please ask. Next raised hand by the Aarti Pawar. If you have any questions, please ask. Okay, no questions. I think, sir, there is no questions.
Okay.
Okay. Sir, on the behalf of all the participants, Engineering College Bikaner and ATAL FDP team, I extend a hearty lot of thanks to you, sir, for sparing your time to this innovative talk, and definitely sure we are going to incorporate your innovative ideas as well as use of industrial concept in teaching and learning process. Thank you very much, sir. It was a nice presentations, and there are a lot of comments come in the chat box. I again
Thank.
thank you so much, sir, for your wonderful interactive session. Next, I would like to thank all the participants who joined us from various part of the nation, without whom this session couldn't be a success. Thanks a lot. Sir, there is a query. Can this PPT be shared with the participants? Number of participants are asking for that.
Yeah, there is no harm. We can. I will send to you.
Thank you, sir. So we will try to share at the end of this FDP. I request all the participants to join at 9:30 a.m. sharp tomorrow morning for the next session. Thank you all for being here with us. Again, thank you, sir.
Okay. Thank you. Thank you, Ranjit. Thank you, everyone.
Thank you, sir.